Okay, let's use the degree 2 Taylor polynomial for the square root function centered at x equals 1 to approximate the square root of 1/2. So I first need to find the degree 2 Taylor polynomial, and we get that by taking derivatives. So my function is x to the 1/2 power. The derivative, 1/2 x to the negative 1/2 power. The second derivative would be negative 1/4 x to the negative 3/2 power. And I could stop there if I were only interested in the degree 2 Taylor polynomial. I don't need to find a pattern or anything like that. I'm just going up to the second degree. So I could stop, but I know I'm going to use my Taylor polynomial to approximate something. And looking ahead, I think I'm also going to want the third derivative. So the third derivative would be 3/8 x to the negative 5/2 power. Okay, so my Taylor polynomial, I could write down. My Taylor polynomial is y of x. It's plugging in 1 here gives me 1 over 0 factorial times x minus 1 to the 0 power. That's the 0th term, the constant term. Plus, plugging in 1 for x here gives me 1/2 over 1 factorial, x minus 1 to the first. And then plugging in 1 to the second derivative gives me negative 1/4 over 2 factorial, x minus 1 squared. So that's my Taylor polynomial. It is 1. This is 1/2 times x minus 1. And then this, I think, will give me negative 1/8 x minus 1 squared. Okay, there's my Taylor polynomial. So the square root of 1/2 is approximately equal to when I plug in 1/2 for x here. So 1 plus 1/2, and then if I plug in 1/2 for x, this becomes negative 1/2. And if I plug in negative 1/2 for x, this becomes negative 1/8 times 1/4. All right. How good of an approximation is this? So what is this actually? So this is 1, I think it'd be minus 1/4 minus 1 over 32. So whatever number that is. How close am I to the actual value? Well, for that, I want to bound on the error. So the error bound says my error is less than or equal to some m over n plus 1 factorial times c. C is the number I'm plugging in. N is the degree of my Taylor polynomial. C minus the center, a, to the n plus 1 power, where this m satisfies some condition. It has to be bigger than or equal to the n plus first derivative of your function for values x that satisfy this condition. So here, my error is less than or equal to m. I'll find that in a second. I'll do the easy stuff first. N is equal to 2. So I get 3 factorial. C is equal to 1/2. So 1/2 minus the center. The center is 1. So I have this to the third power, where I need to write down the third derivative, which I already took over here. So 3/8 x to the negative 5/2 has to be less than or equal to m for values of x that satisfy x minus 1 has to be less than or equal to the absolute value of 1/2 minus 1. So x minus 1 has to be less than or equal to 1/2. So if I plot the values of x that satisfy this condition on a number line, so here I have 0, 1, 2. This says the values of x have to be a distance 1/2 away from 1. So there's 1. The values of x that satisfy this are in between 1/2 and 3/2. So this is my value that I'm allowed to take x in. And I need the m to satisfy this condition right here. Well, this condition, if you rewrite this part, we have 3/8, and then I'm going to write this negative exponent as a division. So I have x to the 5/2 power. That has to be less than or equal to m. Now I dropped the absolute values because if I plug in any value of x in this interval, I always get a positive number. So the absolute values don't really do anything. I'm dividing here by x to the 5/2 power. If I want to make this quantity the biggest I could possibly make it, then I want to divide by the smallest possible number, because dividing by a smaller number makes the whole quantity bigger. So I'm going to take m and I'm going to let it be 3/8 1/2 to the 5/2 power. What I just did there was I took x to be 1/2. That's the smallest number in my range. And the reason I picked the smallest possible number is because I'm dividing. And I want this whole quantity to be the biggest I could possibly make it. So I'm going to divide by the smallest possible number. So that's my m I'm going to take. So my error is less than or equal to this value of m, which I'm going to say is 3/8, well, 3/8, and then I'm going to put this 1/2 on the top, 2 to the 5/2 power, divided by 3 factorial times 1/2 to the 3rd power. So this gives me how bad my approximation here could possibly be. All right, great.